Hello again. So we're now going to talk about discounting when you get an infinite number of terms. So discounting when you get something forever. So you get $10 forever. What's the discounted present value of that? And in order to discuss this, we have to revisit a concept that I'm sure almost all of you had in calculus, and that is the infinite series. So remember, you can have a series of an infinite series, an infinite number of terms, but they can converge to a finite sum. Not always, but they can, as long as each term in the series keeps getting smaller and smaller. So again, remember, infinite series, you have an infinite number of terms, but each one gets smaller and smaller and smaller, and it's possible that this will converge to a finite sum. One series, and we're going to use this a lot, this is a geometric series, I think, and this series is probably the simplest infinite series that converges. And this is just, if you have delta to the 0 plus delta to the 1, delta to the 2, delta to the 3, so on forever. So there's delta to the trillion and 100 trillion and all the way off forever. And as long as delta is between 0 and 1, this series converges to 1 over 1 minus delta. So for example, if delta is 1/2, this series converges to 1 over 1 minus 1/2, which is just equal to 2. So if you take the term 1 plus 1/2 plus 1/4 plus 1/8 plus blah, 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 that converges to be 2. I'm not going to prove why this is right. The proof isn't that hard. Almost certainly had it in your calculus class, and you can find it on the internet if you're interested. But this is probably something that you should know for our tests. So this is, if you could know this this geometric series, that again, delta to the 0, delta to the 1, delta to the 2, delta to the 3, dot, 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 that just means it keeps going on and on and on. That converges to 1 over 1 minus delta. So let's use that to calculate the discounted present value. Imagine that you are given $10 forever starting right now. What's that worth? Well, just from discounted present value, if you're given $10 forever starting now, 10 times delta to the 0, that's, $10 you're getting right now, plus 10 times delta to the 1, that's the $10 you're getting in one period, plus 10 delta to the 2, that's the $10 you're getting in two periods, plus 10 delta to the 3, 4, 5, dot, 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 this just keeps going. Well, we can take out the 10, right? That's 10 times delta to the 0, delta to the 1, delta to 2. I just took out the 10, and then it still has this term. And then we know this is just equal to this. So this is 10 times 1 over 1 minus delta. And say delta is equal to 0.9. The discounted present value is 10 times 1 over 1 minus 0.9, which is 10 times 1 over 10 times 1 over 0.1, which is just 100. So what that means is, let's say your delta is 0.9. Someone promises you $10 forever starting right now. What's that worth? That's worth $100 to you. And delta 0.9 is a convenient discount rate, because if delta is 0.9, then 1 over 0.1, 1 over 1 minus delta is just going to be 10. So if delta is 0.9, if someone promises to give you X dollars starting now forever, what's the discounted present value of that? It's going to be 10x. So you just multiply what you're getting forever starting right now by 10, and that's the discounted present value. Okay, so again, someone offers you a bond, pays $10 a period forever starting right now, discount rate's 0.9, the most you pay for that bond is $100. So another example, someone gives you $7 forever starting right now, but now your delta is 1/2. What's that worth to you? Well, it's going to be worth 14, because you get 7 forever, and then you multiply it by 1 over 1 minus delta. So 7 times 1 over 1 minus delta, and that's 7 times 1 over 0.5, and that's just 14. Right? Because we've got 7 times delta to the 0, plus 7 times delta to the 1, plus 7 times delta to the 2, and that's just 7 times 1 over 1 minus delta, and that is going to be 14. So again, delta 0.5, it's another, it's another convenient discount rate if you don't have a calculator, because 1 over 1 minus 1/2 is just 2. So if you have a discount rate of 1/2, that means someone gives you X forever starting now, the discounted present value of that is 2x. So obviously, delta is 1/2. Discounted present values tend to be a lot lower than if delta is 0.9, because remember, the lower the delta, the less you care about the future. So the less valuable it is to keep getting money into the future. So before we can get to applying this to infinitely repeated prisoner's dilemma games, the final thing we need to go into is a situation where you can't quite use the formula. So now imagine we'll go back to delta's 0.9 and you get 7 forever, but starting in period 1. So remember that now is always defined as period 0. The formulas are a little bit nicer that way. So what if someone gives you $7 forever, not starting period 0, but in period 1? That just means you get $7 forever. A bond pays you $7 a year forever, but you don't get any money this year. It starts next year. That is going to be worth less money than a bond that pays you $7 forever starting right now. But how much less? Well, there's, a formula for that, but I'm not going to have you learn another formula. We can recover and get back to our original formula pretty easily. So, ignore this bracketed term for a second. What you're getting is 7 times delta to the 1 plus 7 times delta to the 2 plus 7 times delta to the 3 plus forever, right? We're trying to calculate this right here. But we don't have a formula that has an infinite number of deltas that start at 1. We've got a formula for an infinite number of deltas that start at delta to the 0. Uh-oh, what do? Well, there's a simple trick. I take what I care about and I add 0, but it's a special kind of 0 that'll help me solve the problem. So remember, I'm always allowed to add 0 to something. If I'm trying, I have x. That means I have x plus 0, right? It has to be. X has to be equal to x plus 0. But there are a lot of ways of writing 0, right? X is equal to, x plus 5 minus 5. X is equal to x plus 8 minus 8. So there's a lot of ways I can write 0. And sometimes when, you're playing with math, trying to get a formula to work, you can find a 0 that allows you to use your formulas. The 0 I'm going to use is negative 7 delta to the 0 plus positive 7 delta to the 0, right? This is 0. Cancels out. So this is what I care about. Remember, I want my discounted present value of getting 7 forever starting in period 1. So that's 7 delta to the 1, 7 delta to the 2, plus. And I add this special 0. Okay, I'm allowed to do that because it's just 0. I can add 0 to something, doesn't change it. But then take away the brackets. And what do I get? Well, I have this term, but then I got 7 delta to the 0 plus 7 delta to the 1, 7 delta to 2. Wait, I know how to calculate this part. Ignore this first term. The rest of this, that's my regular formula. That's just 7 times 1 over 1 minus delta. So all of this stuff here, going off forever, is just this. And then I got this left over. And of course, remember, anything to the 0 is 1. So this is just 7 times 1 over 1 minus delta minus 7. And, 1 over that is going to be 63. Another way to look at this is how you could have figured this whole thing out in your head. So remember, delta's 0.9. What's the discounted present value of getting 7 forever starting right now if delta's 0.9? Well, delta's 0.9, right? 1 over 1 minus 0.9 is just 10. So remember, getting 7 forever, delta is 0.9, 7 forever starting now, delta's 0.9, that's worth 70, right? You can do that. You should be able to do that in your head. Okay, but now I'm not getting 7 forever starting now. I'm getting 7 forever starting a period from now. How much worse is that? Well, I'm losing the $7 right now. But what's the value of getting $7 right now? What's the discounted present value of getting $7 right now? It's got to be $7. The discounted present value is always asking, what is the value today of that promise in the future? Well, the value of getting $7 today is $7 today, right? The discounted present value of money today is just money today. So it's got to be worth 7 less to get a promise of $7 forever starting in period 1 than it is getting 7 forever starting in period 0. And we know getting 7 forever in period 0 is worth 70. So this is what we get. This has to be, again, what it is. So to review, the way to use our formula if we don't quite have the 0 term is to add this term and then take it away again. Then, when we added it, we can use our formula. I can use a formula on this part, and I've got this left over, but that's easy because delta to the 0 is just 1. So it's just minus 7 times whatever I would have gotten had I gotten the money starting in period 0. And we'll be doing examples of this, so I know this is probably a tad confusing, but we'll be doing examples of this, and hopefully it will be clearer. Thank you very much.